Okay, chapter 7-2, properties of exponential functions. This is review from chapter 2. In chapter 2, we talked about up, down, left, right, stretch, reflect, and compress, all that jazz. You remember that? Okay? Now, given f of x is equal to negative 3 times x plus 2 squared minus 4, let's talk about what parent function goes with this function. What is the parent function? It is a parabola, which is going to be y equals x squared, and that looks like a u. Do we all agree with that, yay or nay? Now, if that's the parent function, what I want to know is what did you do to that? Did you pull it by the vertex and stretch it, compress it? Did you just pick it up and slide it left and right, up or down? What did you do to it? So with that said, we need to review a little bit of what a compression is. So if I have my parabola like I have right here, what is the compression?
Compress it to make it fatter.
So you push the arms down to make it fatter. So if you're compressing, you're making it fatter. Think of compressing trash, or think of pistons firing if you are in automotive or something like that. There's pressure that goes down that piston to make it expand and, fire, right? Y'all with me on that? Yeah. So it's pressure, it's going down. So with that said, this puts the arms, pushes down, push arms down, and that means that mathematically, you multiply by a fraction. So mathematically, when you have a compression, you're actually multiplying by a fraction. Now, if that means that you push the arms down for a compression, and I have y equals x squared, what is the stretch with y equals x squared? What would I do with my arms then? If you're stretching, what do you immediately do? You stretch out, which means you make them longer, which means you're pulling the arms up. Okay? Mathematically, what that means is you're multiplying by a value greater than 1, meaning it is not a fraction. So if I'm multiplying by a value greater than 1, I'm talking about 2.5, 5, 100, 133.2. Those are all values greater than 1, and that make it a stretch. Now, how do I reflect a parabola of y equals x squared? How do I reflect it? Flipping it down over the x-axis would be a reflection, but how do I do that on the equation? What? Well, we've multiplied by a fraction. We've multiplied by a number greater than 1. We have not multiplied by a value less than 1. So this means you're going to multiply by a value that is negative. So you're going to multiply by a value that is negative. Now, what's a translation do? We've talked about multiplying everything by. What is a translation? What does the translation do? It moves it up, down, left, right. So we have up, bless you, down, left, and right whenever we're talking about a translation. Do we all understand that, yay or nay? Okay, that is all what we have done for review. Now, if we go back up here and we talk about this handy-dandy little equation that I gave you, what is going on with that negative 3? The negative does what? It reflects it over the x. And what does the 3 do?
It's the stretch.
It's a stretch by a factor of 3. What does the 2 do? I'm sorry? No. What does it do? It's a translation, but what does it do? Up, down, left, right.
Up, down,
Opposite of what you think. You think it would go right, so it's going to go the opposite. It's going to go left 2 units. And then what is the last one of minus 4? It's going to go down 4. Okay, now that's all review from what you have learned in chapter 2. Now today, what we're going to do is we're going to add another parent function. So the next parent function that we're going to add is an exponential parent function. So that's y is equal to a times b to the x. Understanding that a was your initial value, and b is your growth or decay model, correct? Now, are we ready? You do not have to write all this stuff down. All you have to do is write down the equations to compare them. So here I give you 2 equations, f of x equals 2 to the x, and f2 of x equals 3 times 2 of x. Now my question to you is what did we do with it? Now what am I multiplying by? I'm multiplying by a value of 3. So if I'm multiplying by a value of 3, is that negative in between 0 and 1 or greater than 1? It's greater than 1, so is it a reflect, a compress, or a stretch? This is going to be a stretch by 3. And what does that mean graphically to these things? Well, let's think about this. The red graph has a y-intercept of the point 0, 1. True statement? Now, in order to be a stretch, what that means is what's changing are your y values. Your y values are what change, which means all I'm doing is taking my y value and multiplying it by 3 to give me the point 0,3. Well, that point 0,3 should be the y-intercept of the other graph. And my question to you, is it? 1, 2, 3. It sure is. Do you see I have the point 0,3? So whenever you stretch a graph, the y values are what changes. Do we all see that? So going to the next one, I have 1/3 times 2 to the x. Is 1/3 negative, a fraction, or a number greater than 1? A fraction. So are you reflecting, compressing, or stretching? You are compressing. And I did not give up. You are compressing. And you're compressing by a factor of 1/3. So what does that mean? Compress means you're pushing down the y values, correct? How are we mathematically pushing down the y values? Well, what we're doing is we're taking this y value, which is the point 0,1, and I'm simply going to multiply that by 1/3. So my value that I'm going to be having is going to be the point 0,1/3. Do we see that, yay or nay? Okay, so we all understand how we get this. The y value is the one that changes again when you stretch or compress. Agree? Does the x value change any time? No, the x value does not change. So let's go on to the next one here. I have f of 2x is equal to 2 to the x minus 4. The minus 4 is in the exponent position, correct? The minus 4 is in the exponent position. So my question to you is what's happening to this graph? Is it? The red function is the normal function. So here's my y-intercept, 0, 1. What's happening to that point 0, 1?
It's going to the right 4.
It's going to the right 4. So what I have is a translation. And the translation is going to be going to the right 4 units. And why is it going to the right 4 units? Because it's the opposite of what we think it is. We think it's going to the left because of subtraction, but we're really going to the right. So with that said, what happens to these values? So if I'm going to the right, 1, 2, 3, 4 units, here's my lovely little point. What is that ordered pair? What is that? 4, 1. Well, how did I go from 0, 1 to 4, 1? What happened? What changed is I have a horizontal shift, which means I'm taking the point 1, 0, and I'm adding 4 units to the x to get the point 4, 1. So in a horizontal shift, what values change, x or y? The x values are the ones that change. The x values are the ones that change. Do we understand that? You should be writing that down because you're not going to have this later on. Okay? Okay, now, look at this one. I have 2 to the x plus 4. What do you think is happening to that?
It's going to go to the left.
It's going to go the opposite position of where you think. So this is still going to be a translation, but the translation is going to be going this time left 4 units. Well, let's look at my lovely little y-intercept. Well, my y-intercept is going to be the point 0, 1. Now, if I'm going to go to the left 4 units, 1, 2, 3, 4, I now have the ordered pair what there?
-4, 1.
Now I have the point -4, 1. Well, how did that change from 0 to -4? What did I do to it? I subtracted 4 units off my x because that is a horizontal shift, and that is what is changing. Did the y value change here? No, the only thing that changes is the x value. Did we all see that, yay or nay?
It's the only one that the X value
So far. Okay, what about this one? 2 to the x minus 4. What's happening this time?
That's gonna put Y value.
The whole graph is going down. How many units? 4 units, right? So now from here, I am basically going to go down 1, 2, 3, 4 units. So now I have a new point. And what is that point? 0, negative, 1, 2, 3. Why is it 0, negative 3? That doesn't make sense to me. What did I do?
You subtracted 4.
I subtracted 4 from what?
Y.
I took my y coordinate and I subtracted 4 units off of it, and that's where I'm getting the 0, negative 3. So when you have a vertical translation, what happens is the y coordinate changes. The y value changes. Do we understand that, yay or nay? Okay? We good? Okay, well, what about this one?
It's gonna go up.
It's going to go up. Check out here. I have my y-intercept. It's the point 0, 1. From there, this entire graph is being picked up from that y-intercept and going up 1, 2, 3, 4 points. Now, if that means I have a translation of going up 4 units, how am I getting that ordered pair? Well, this ordered pair is going to be the point 0, 5. How am I getting 0, 5? I'm adding 5 units or 4 units to the y value. So what do we learn here? The y value changes. Do we see that? Okay. What about this one? Reflection over what?
X-axis.
It's a reflection over the x-axis. Okay, now let's really think about that a minute. I have this lovely little point, which is the point 0, 1. How am I going from 0, 1 down to this point, 0, negative 1?
Counting by,
What did you just say, Nick? You're multiplying your y value by a negative 1. So you're going to have a reflection over the y-axis, over the x-axis. What this entails is you're going to take your y coordinate and multiply it by negative 1. Okay, so it's negative 1 times your y value. Whatever y value you have, the only thing that changes is going to be your y value. Your x value does not change. Do we understand that? Okay, so now what about this one? That's a reflection over the y-axis. Now, we have an issue looking at the y-intercept here. Why do I have an issue looking at the y-intercept? They're both the same. So what you actually have to do is do a little calculation. What's 2 squared? 4. So now I'm going to have the point 2, 4. So here's 2 and here's 4. 1, 2, 3, 4. There's my point. Now what's happening to that to be reflected over the y-axis? I folded it, didn't I? I folded it right over that y-axis, which means I can have equal distance between the y-axis and the point 2, 4. So what's that ordered pair going to be? Negative 2, 4. So what you did here is you took your x value and you multiplied it by negative 1. And your y value stays the same. Now, tonight for homework, what you guys have, stop, clean it up and pay attention. I did not get far with you guys today, so what you actually have is just the front page to do. You're going to have to do some x-axis or some XY tables and graph them. Okay? If you see a decimal like 0.12, what is 0.12 the same thing as? Isn't 0.12 the same thing as 12 over 100? Yeah. what is 12 divided by 4? 3 over 25. Is that hard math? Homework due tomorrow.
You want to quit?
Yes, I'll